Hello everybody and welcome to the Creatrix YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we'll support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, up to now what I have taught you is we have discussed about DC analysis of BJT. Then we have seen the AC analysis of BJT as well as the frequency response. But the common thing in all these things is we were only considering one BJT. So whenever we were discussing amplifier problems, we were only considering one BJT, and that is called as a single stage amplifier. That is, the gain was being provided by a single stage or a single BJT. But now what we'll be studying is multi-stage amplifier. That means when multiple transistors are used instead of a single transistor to amplify the input signal or to provide the gain. But the first question that comes to mind is why we need to use multiple BJT instead of a single BJT when we can amplify the signal using a single BJT. So the first drawback of a single stage amplifier is that the gain is less for a single stage amplifier. The second disadvantage is input and output resistance requirement. Input and output resistance requirement cannot be met. Okay, that means if you need a high input resistance and low output resistance, you cannot obtain it using just a single stage. Third one, poor efficiency. Now what is meant by efficiency here? I told you when we talk about an amplifier, it absorbs energy from the DC biasing and then it supplies that energy to the AC signal and increases the amplitude of the AC signal. So that is called as conversion, and the efficiency is defined as the ratio of useful energy, that is the energy being transferred to the AC supply, upon the energy absorbed from the DC supply. Because BJT will absorb some energy from DC but it will not transfer the entire energy to AC. So that is why this is called as efficiency, and efficiency is very less for a single stage amplifier. Now we have already seen that the product of gain into bandwidth is constant. So in multi-stage amplifier, what happens? In multi-stage amplifier, the gain of the amplifier increases, due to which the bandwidth will decrease. Now why I am so concerned about bandwidth? If you see the response of the amplifier, the frequency response that we have studied, the frequency response was somewhat like this. Then we took the 3 dB gain, and this was lower cutoff frequency, this was upper cutoff frequency. This is called as your bandwidth. Now if you see why bandwidth is important, because inside bandwidth the gain almost remains same. Now we don't want the gain of an amplifier to change with the frequency, we want it to provide a constant gain. That is why we want to operate in the mid frequency region, not in the low frequency or the high frequency region, because we want to derive a constant gain. So if you want to stay in the mid frequency region for any input frequency, the mid frequency region should be wide or the bandwidth should be high. So how you can describe the bandwidth? Bandwidth is the range of frequencies at which the amplifier provides a constant gain. And since we want a constant gain, the bandwidth should be high or most of the frequencies should lie inside the mid-band region. Okay, so that is why bandwidth decreasing is a disadvantage. Now we can cascade. Cascade means supplying the output of a device as an input to the other device. Cascading means that. Non-interacting means that there is no current flowing from one stage to the other stage. Non-interacting stages means, again I am repeating, no current flow between two stages. So if I show you, suppose we have three stages. Like this. This is suppose voltage gain AV1, it has AV2, it has AV3. Now cascading means the output of one stage will act as the input to the next stage. Non-interacting means there is no current flow between the three stages. So how can that happen? That can only happen when the input resistance of any stage tends to infinity and the output resistance tends to 0. If the input resistance tends to infinity, the input loop will be open circuited. What I mean to say is, suppose I draw a simple circuit. Suppose this is the resistance Rs, this is R pi. Now this is Vs. So what will happen if R pi tends to infinity, the current input to this stage would be 0. So that is meant by non-interacting stages, that the next stage should not draw any current from the previous stage. Okay. And why is it ideal condition? Because in such case V pi will be equal to Vs. Okay, the entire voltage will be acting as the input to the amplifier, or there will be no voltage drop across the internal resistance, or you can say no voltage drop across the source resistance Rs. So that can only happen when input resistance is infinite. Is it fine? Why output resistance must be 0? Because when you show a current source like this GM V pi, or let me draw a voltage source actually. Suppose we have a voltage source here, then we have a load. Suppose this is voltage gain into V pi. So we want the entire voltage to appear across the load and no voltage drop across R0. That is why ideally R0 must be 0, so that the entire output voltage appears across the load. Now when non-interacting stages are cascaded, we say that there is no loading effect. Now the question that strikes the mind is, what is this loading effect actually? So loading effect means when the next stage draws current or power from the previous stage. If it is drawing current, it is drawing power. If it draws power from the previous stage, it works as a load on the previous stage. Now since it is not drawing any current or power, it is not acting as a load, and that is what I am saying as no loading effect. Are you getting my point? There is no loading effect if the stages are non-interacting. Now like we studied in control system, when there is no loading effect, the overall voltage gain is the product of all the voltage gain. In control systems we said that the overall gain or the overall transfer function is a product of the transfer function in case of no loading effect. Now we say if stages are identical, if all amplifiers that you are cascading are identical to each other, then the overall voltage gain is individual voltage gain to the power n. I am cascading n stages, and that is why I am saying overall voltage gain is individual voltage gain raised to the power n. Is my point clear to you? So remember, you can just multiply the gain of the stages if and only if there is no loading effect, or you can say the next stage does not draw any current or power from the previous stage. Now I know what happens to the gain. I want to know what happens to the bandwidth. For that, what I have to do is, let me remove this much. So I'll use this logic only, that the gains are being multiplied when non-interacting stages are cascaded. So first let me talk about the low frequency. The low frequency gain we derived was this I am talking about a single stage amplifier, what we studied in frequency response. Mid frequency gain 1 plus FL by F whole square. This was the gain. Now suppose n such stages are cascaded, so what I will say, AV dash in low frequency is AV low frequency to the power n. N gains are multiplied, so it will become AV mid to the power n 1 plus FL by F, it was under root, so n by 2. If you raise the power of under root to the power n, it will become n by 2. Now what I know is that, suppose at frequency equal to FL, what is this capital FL? Lower cutoff frequency of multi-stage amplifier. We know at the cutoff frequency what happens, the gain becomes maximum gain by root 2. The maximum gain of multi-stage amplifier is mid frequency gain to the power n. It happens at what frequency? It happens at small f equal to capital FL. So I'll put small l equal to capital FL. Now this gets cancelled. If you square both the sides, you will get 2 equal to 1 plus small FL by capital FL to the power 2 to the power n, or you can say 2 to the power 1 by n 1 plus small FL by capital FL to the power 2. Small FL is the lower cutoff frequency of single stage amplifier. Capital FL is the lower cutoff frequency of multi-stage amplifier. So what you can say is small FL by capital FL square is 2 to the power 1 by n minus 1, which means capital FL is small FL by under root 2 to the power 1 by n minus 1. Okay. Similarly, from here what you can say actually is this is greater than capital FL. Now similarly what you could have done is, for high frequency we know the gain is mid frequency over under root 1 plus f over fh square. Then we could have said that for multi-stage amplifier, the gain at high frequency will be the individual gain to the power N. Now what is the difference in the basic gain? Here we had the term FL upon F. Here we have F upon FH. That is, the ratio is reversed. Earlier we had FL by F. Now we have F by FH. So if you solve by similar method, I can say that since we have taken reciprocal of the ratio capital FH, which is upper cutoff frequency of multi-stage amplifier, will now be equal to small fh 2 to the power 1 by n minus 1 under root. So this is basically less than small fh. Now you can see that earlier bandwidth of single stage was small fh minus small fl, which is actually approximately equal to small fh, and the bandwidth of multi-stage is capital FH minus capital FL, which is capital FH approximately, and it is less than small fh. So we can say by the use of multiple stages, the effective bandwidth is reducing. Okay, and this I can also show in terms of frequency response. How I will show? So we know by the use of multiple amplifier we are increasing the gain, but at the same time we are reducing the bandwidth. So how you will show this in frequency response? This is gain. Always remember this gain is in dB. This is frequency and it is in log scale. Now what happens? Earlier the frequency response was like this. This was small fl. This was small fh. Now what happens? The gain increases. The gain increases, but at the same time the bandwidth reduces. So this is your capital FL. This is your capital FH. So now you can see the height has increased, but the width has reduced. So that means the bandwidth has reduced as compared to a single stage amplifier. Okay. So this formula is like FH equal to small fh 2 to the power 1 n minus 1 under root, and capital FL small fl divided by 2 to the power 1 by n minus 1 under root. These formulae are important from numerical perspective, but remember, by cascading multiple stages we can increase the gain, but at the same time bandwidth will reduce. Now what happens if the stages are interactive? That is, if input and output resistance are finite and non-zero, then what happens? Then what I do is, I'll draw these stages. This is a symbol of an amplifier. We generally see this symbol in op-amp. This is the first stage. It has an input resistance Ri1 and it has an output resistance Ro1. Then we have the next stage. It has an input resistance Ri2 and it has an output resistance Ro2. Then we have third stage. It has an input resistance Ri3 and it has an output resistance Ro3. And then we have the load resistance RL. Okay, so that is how we have cascaded the three stages. Now if you see from the input side, what is the input resistance? The input resistance is Ri1. If you see from the output side, what is the output resistance overall? R03. That is, input resistance is always decided by the first stage and output resistance is always decided by the last stage. Now due to this output and input resistance, there will be voltage division. Okay, like we saw voltage division factor when we were calculating overall voltage gain, same sort of voltage division will happen here. So what is the overall voltage gain of first stage? Ideal voltage gain into voltage division factor, Ri2 by Ri2 plus R01. Overall voltage gain of second stage, voltage gain ideal, Ri3 plus R02. Voltage gain of third stage, AV3 into RL by RL plus RO3. So that is how we can find out the overall voltage gain. Now the overall gain will be A1, A2 and A3. So in interacting stages means where the current will flow between the stages, you have to make sure that you take into account the factor of voltage division when calculating the gain of each stage. In such cases, what is the band lower cutoff frequency? In interacting stages, 1.1 under root FL1 square, FL2 square plus FL3 square, and so on if there are other stages. Similarly, what about FH? For FH we say 1 by FH is equal to 1.1, 1 by FH1 square, 1 by FH2 square, 1 by FH3 square. Okay, that means the formulae that we have studied so far for the upper and lower cutoff frequency of multi-stage amplifier are not applicable for interacting stages. They are only applicable for non-interacting stages. Now there is one more concept, that what about the rise time? Generally, rise time is taken as 0.35 by bandwidth. So as bandwidth reduces, the rise time increases. So that is why in such case, how do we define rise time? Rise time overall is given as 1.1 TR1 square plus TR2 square plus TR3 square. Okay. So rise time will increase, lower cutoff frequency will increase and upper cutoff frequency will reduce. But these formulas can be applied in interacting stages. The earlier formulae about 2 to the power 1 by n, those formulae are applied in non-interacting stages. Okay. So that is general discussion about the multi-stage amplifier. Now when you connect two amplifiers or when you cascade multiple amplifiers, then they are said to be coupled. Coupling, what does it mean? It means connecting two stages by means of certain circuit elements. Okay, that is your coupling. So what is meant by RC coupling here is that the two stages are connected together by means of capacitor and resistor. How can you show this? Suppose I have a common emitter amplifier. The output will be taken from collector. Now this will work as an input to the second stage. But before connecting to the input, we will pass it through a combination of R and C. That is called as the RC coupling. Now what are the advantages of this kind of coupling? The advantages are that when we are solving for DC analysis, or you can say biasing. Capacitor will be treated as open circuit. So it means there is no connection between stages. Okay. Or you can say Q point of each stage is independent. Is my point clear? Because the stages are not connected together when we are doing DC analysis, so their Q point will be separate. There will be no relation between the Q points of the different stages. So that is called as Q point is stable. Why stable? Because Q point will not fluctuate from stage to stage. The Q point of the two stages are not related to each other. Also, what you can do is you can decide the Q point of any stage independently of the previous stage. Now the disadvantage. Disadvantage is poor low frequency and high frequency gain. Why is it poor? Low frequency is poor due to coupling and bypass capacitance. High frequency is poor due to stray and the parasitic capacitance. So the frequency response of a RC coupled amplifier is somewhat like this. It is high in the mid frequency region and it is low in low frequency and the high frequency region. So that is why if you want to operate in mid frequency, then RC coupling is best, but its response is not good at low and the high frequency. Then we come to second category, direct coupled amplifier. Direct coupled means there is no element between the two stages. That is, output of the first stage is directly fed to the input. Now, as you might have directly understood, now during DC analysis, the stages are connected together. If the stages are connected together, their Q points are not independent. The Q points of the two stages will depend on each other. They are not independent of each other. So that is why we say that Q point is unstable, or it will fluctuate from stage to stage. And this application we will see in op-amp. In op-amp we use direct coupling, due to which DC biasing or DC Q point shifts from stage to stage, and we have to use a specific circuit to bring it back, called as the level translator. Okay. In order to bring back the Q point to its original or the desired value, we have to use a circuit that can change the DC level, which is called as the level translator. Okay. Now what are the advantages? That is better low frequency response. I told you at low frequency coupling capacitor destroys the response. So it has better low frequency response and can amplify DC signal, because earlier in case of DC the stages were disconnected. If the stages were disconnected, the DC signal cannot pass from one stage to the other, so you cannot amplify a DC signal. But here, since the stages are directly connected, we can amplify a DC signal also. So how the frequency response looks like? We have improved the low frequency response but not the high frequency, because high frequency gain is low due to parasitic and stray capacitances. They are not removed. We have just removed the coupling capacitor. The third is called as the transformer coupled amplifier. That means transformer will be used between the stages, and we very well know that transformer is not a small device and transformer cannot be fabricated on chip. Transformer is not such a device which can be fabricated on a chip. it is bulky. That is why it is always used in the final or output stage. We don't use it in the intermediate stage. Suppose there are 10 stages, then transformer will only be used in the 10th stage. It cannot be used at any other intermediate stage. Now how you will show this? Suppose we have a common emitter amplifier, then the voltage output will be across collector and emitter. So we will connect a transformer here. The primary and the secondary winding of transformer will be coupled by means of magnetic field, and here we will have a load resistance RL. Now the turns ratio of this transformer is N1 is to N2. So how does the frequency response of such an amplifier looks like? It looks something like this: gain versus frequency, like this. Now why there is a small spike? It is due to resonance phenomena. Why resonance phenomena? Because we know in BJT we have parasitic capacitance. Now you have introduced inductance. Transformer is nothing but a coil, so it has inductance. Earlier there was only capacitance, now there is inductance and capacitance. So this F resonance is 1 by 2 pi under root L into Cp, where L is the inductance due to transformer. Now what are the advantages? What are the advantages of transformer coupling? First, it can offer impedance matching. That means impedance matching is done for maximum power transfer. That is by varying the turns ratio. We can make sure that RL is equal to R0 into N2 by N1 square. That means if you refer output resistance to the secondary, if it is equal to RL, then maximum power can be transferred. And for that purpose, you can vary the turns ratio so that we can operate under the condition of maximum power transfer. It has efficiency of about 50%, which is considered to be high when we talk about electronics. Okay, this efficiency is very low when we talk about electrical circuit, but it is high as per electronics. Now what are the drawbacks? What are the drawbacks if I talk about drawback? Transformer is bulky, costly, okay, and last one, poor frequency response. Because at low frequency and high frequency we see that the gain reduces, so that is a poor frequency response. So these are the three type of coupling techniques that we generally use, and we will see in the op-amp we will make use of direct coupling. So let me summarize what we have learnt in this lecture. We have first seen the need of multi-stage amplifier to satisfy the input and the output resistance requirement, as well as to increase the gain of the amplifier. Then we have seen in case of non-interacting stages, the upper cutoff frequency becomes FH 2 to the power 1 by n minus 1 under root, and lower cutoff frequency FL 2 to the power 1 by n minus 1 under root. Then we saw in interacting stages we have to make use of voltage division, and we also saw that FL was 1.1 under root FL1 square plus FL2 square and so on, and 1 by FH is 1.1 under root 1 by FH1 square plus 1 by FH2 square and so on. Then last we saw there are three methods of coupling: RC coupling, but here low frequency response is poor due to coupling capacitor. Direct coupling, low frequency response is good but Q point is unstable. And the last one is transformer coupling, which is basically used in output stage of the amplifier and it makes the circuit bulky. So this is the basic of multi-stage amplifier. In the next video we'll see some of the circuits that employ this strategy of using more than one stage. That we'll cover in the next video. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JEE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these 2 channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.